Okay, so again, welcome to EM1202. That's Integral Calculus, and again, I'm your instructor. So, Oliver Dave Maguyon. So, I am a civil engineer. So, let's begin with the first topic. Okay, so our outline for today's discussion will be only up until the basic formulas. So, we're going to have the introduction, so what integral calculus is all about. Then afterwards we'll go to the basic formulas or the basic processes of the integral. Then once we know the basic stuff, so next meeting we'll go to the advanced topics, which is the transcendental functions, and it comprises of 4 different types of functions. So we have trigonometric, inverse trigonometric, hyperbolic, and exponential. So again, we're only up until the basic formulas today. Okay, so in differential calculus, so a derivative or differential is obtained by, of course, differentiating a given function. So for example, you have this particular expression, you have x cubed plus 4. So again, in our derivatives or in our calculus 1, so what we did in calculus 1 was to get the derivative of this function, di ba? So as you can recall, so pretty easy na kayo ni siya. So the derivative of this function is 3x squared, di ba? Then plus 0, because the derivative of a constant is 0. So your final answer would be 3x squared, and that's the derivative of the function. Now, the purpose of having the integral is, for example, muna siya ito ang given expression. So the purpose of integrating is for you to get back to the original equation, which is x cubed plus 4. So muna reverse process na siya compared sa inyong derivatives nga going forward, so kani siya is going backwards. So I think mura na dyan na siya inyong button, and to think of it, if you are just deriving basic stuff, so integrating would be easy also, but when we go to the advanced expressions or advanced functions, so medyo kailangan siya mga different techniques or processes. Okay, so we have verified that the derivative of this equation is 3x squared. So again, if we try guessing the original equation, di ba? Kani siya. So again, if we try guessing the original equation of this particular derivative, so we can say nga the equation could be x cubed, di ba? X cubed only. And then the original equation is x cubed plus 4. So what I mean here is, for example, if you are only given 3x squared, so for example, you're not given x cubed plus 4, you don't know that the original equation is x cubed plus 4, and you want to guess the original equation of this particular derivative, diba? You want to know the original equation. So we can say that by guessing, so we can just say that the equation it came from is x cubed, diba? Yeah, ang original equation is x cubed plus 4. So again, by guessing na siya. So of course, if we try to get other possibilities, so for example, kani siya, di ba? So those equations are still possible derivatives of 3x squared. So as you can see in the first term, kani siya. So these first terms all achieve the 3x squared na derivative. And of course, the second term, as long as these are constants, so the resulting derivative will still be 3x squared. Diba? So daghang kay possibilities nga makuha ani nga kuan nga derivative by getting the integral. So our findings is that the different constants have the same derivative, diba? As you can see here. So regardless of what particular constant we have, pi or phi bar or -2, so the resulting derivative is the same because the first term are all x cubed. So again, take note that the possible equations are not the same as the original equation, but we are basing it on the given derivative. Okay. Okay, so by this, again, if we try to integrate later on, we can have a general answer for the x cubed plus the constant, diba? And we can express this one as c. So instead of guessing what particular constant you're going to have, and again, since we were not given the original equation later on, so atong bato na instead of guessing what constant the given equation is, so ato siyang let it as c. Okay? So may mo siyang x cubed plus c. Okay? So again, plus c lang siya. So again, if you're going to ask me how we're going to get the value of c, so that will be in your next subject next semester, which is the next math to integral called differential equations. So by that subject, you can now solve the particular constant that we have solved in this integral. So that will be next semester. So again, our interest here is for you to know the process of integration because the techniques that I'll teach you this semester will be important in the next subject. So in differential equations, it will be a combination of calculus 1 and calculus 2. So derivatives and integration. So questions so far or clarifications? Okay, so let's proceed to the next slide. Okay, so by definition of your integral calculus, so in most books, so it's not called integral, but they call it as antiderivative or antiderivative. So the function f of x is an antiderivative of f of x. So in this first statement, so the function f of x is an antiderivative of f of x. Okay, so meaning the big f of x is your particular integral. So muna siyang ato ang gi-integrate. And this one is the given derivative. Or muna siya ang iyahang katong output ganina. So for example, muna siya ang ato ang 3x squared ganina. And then this function is, that's what we call the x cubed, the original equation. Okay? So if f prime of x, so again, if there's a prime, so that's the first derivative, di ba? Is equal to f of x for all of x in the domain. So the set of all antiderivatives of f is the integral of f with respect to x, denoted by the integral of f of x. So in this second statement, kaning f big F prime of x is equivalent to f of x. So meaning if you're going to derive this x cube, di ba? Again, x cube is the big F of x. So again, if we're going to derive this one, so dapat equal siya aning inyong f of x, di ba? So mura siya kanang, it's a reverse process na siya. So derivatives, then if you want to go back to the original equation, you integrate or you get the antiderivative. So mura na siya. Okay, so in calculus terms, so with all the words being presented, so we have the integral or the integral of f of x with respect to x is equivalent to the particular integral of the big f of x plus the constant plus c. Now defining the different parts, so of course this one is the integration symbol or the integral sign or the integral sign. It's also called the elongated s, and it's the first letter of the Latin word summa. So later on, one of the applications of your integral calculus is summing up areas, volumes, lengths. So muna siya itong button. Okay, so the small f of x is the integrand. So we don't call it the derivative anymore, but it will become the integrand or the integrand. So if you search up online, so there are many ways to pronounce these words. So this will be your integrand or the equation that you need to derive. So the big f of x is the particular integral. So meaning that's the resulting equation that you have integrated from the integrand. So ganina is, let's say our integrand is 3x squared. So what we have achieved is the x cubed, diba? Plus c. That's your particular integral. Okay, so dx indicates that x is the variable of integration. So meaning, kung puro siya x, so meaning ana, ang x na sa nga variable ang inyong i-integrate. So later on, when we go to multiple integrals, so kung siya, may mo siyang dx, dy, dz, ana. So mura siya partial derivative ninyo. So you only need to integrate what the particular variable of integration is asked. So if x sa na inyong integrate. If y, so meaning y is the variable of integration. So again, we are not limited to the x variable, but the equation could be in terms of other letters. So it could be z, it could be y, it could be letter t, it could be r, so depending on the given equation. Okay, so lastly is the constant of integration, and usually in books it's termed as arbitrary constant. So muna siya nga to ang unknown parameter as of now, but again when you reach the higher mathematics, differential equations, advanced math, so you'll know the particular value of the constant. Okay, so the final answer, the big f of x plus the constant of integration is what we call as the value of the indefinite integral. So why do we call this indefinite? Because kung tanawin niyo ang inyong integration symbol, so the integration symbol has no limits. So if you try to observe your calculator, so na siya yung murag function diya nga murag ana naka-box diri ana. So you have the integral sign, and then there are boxes diri sa inyong calculator. So these boxes are the limits of integration. Then usually the limits will be applicable in the second half of the semester. So in the area, in the volume. So muna siya inyong i-discover later. Okay. So far so good. Okay, so let's proceed. So antidifferentiation is the process of finding the antiderivative, and it's also called integration. So if you look at the slide, so kani siyang antidifferentiation is the same as integration. So pwede rin na siya isumpay diri. So ako lang ilahi. But again, that's called the same lang. So anti-differentiation or integration. Or getting the integral or getting the antiderivative. Okay, so integration is the process of finding the function whose derivative or differential is given. Okay, so let's go on to the basic formulas. So these formulas show that u and v are differentiable functions of x. So letters a and c are constant. So take note of this one. So we have 5 basic formulas. Excuse. So the first one is just the derivative of a constant. So this one is constant. So why constant? Because if you look at the equation, so that's the integral of 1, di ba? With respect to u. Diba? So of course getting the derivative, I mean the integral, that's u plus c. So of course if you want to check if it's correct, diba? So the derivative of u plus c is equivalent to 1 du, diba? Plus 0. Then the final answer is du. So muna siya dire. So basic, diba? So for the second and third formulas, so it's more likely of a property, not a formula. So murag distributive property siya, di ba? Dili siya formula. So what we did in the second and third is that distributive property. So distribute dx to the terms. So you have two integrals now. So integral of u with respect to x plus integral of v with respect to x. So again, take note that u and v are differentiable functions of x. So meaning the equations of your u and your v are all in terms of x. So let's say it could be x cubed plus 4, di ba? Or this one could be 3x squared, pero So take note that since we have two integrals present now, so this first integral will generate one constant. So let's say c1, and then the second integral will create a second constant. But since both are the same constants, so you can just group them together into one big constant. Diba? So para dili kay mo magkuhan, basta marag ang ultimate tip ani is always put plus c at the end of your answer. Na para pwede lang mo dili magsigig butang-butang og c sa each integral process. Okay. So for the third property, so again, it's not a formula because murag ko na siya kanang algebraic property ra siya. So in the third formula, so a is constant. So what we did here is to take the constant outside the equation and deal later with the constant. Okay? So muna siya gi-factor out ang ato ang constant and then you work with the integral of u with respect to x. So the resulting answer is, of course, before we came up with au plus c, so ana na siya ang labas, di ba? So for example, u plus c na siya, ana. So the answer is, of course, if you multiply is you distribute, di ba? So au plus a times c. So again, take note that since a and c are both constants, so instead of putting AC, so pili ra po siya big nga C, di ba? Okay, puro man siya numbers ra. Unlike your U expression, since it's a function of x, So whatever you multiply with the constant, so murag ma-change ang iyang appearance. Now, a constant is, if you multiply it with a big number, it's still a constant. And then, since we don't know the value of your constant, so might as well make it unknown gyapon all throughout the process up until the final answer. So, man siya dire. So, you might wonder ng ano C na siya, di ba? Walay A. So, that's the explanation. Okay, so in the fourth formula, this one is the exponent rule of integral of integration. So if you have the exponent rule in your derivatives, so you also have the exponent rule in the integral. So in your derivatives, so since we took one exponent, so since we are reversing the process, so what will happen here is we're going to add 1, diba? 1 exponent. And since we atong gi-bring down ang exponent, diba? Nahimo siyang coefficient sa inyong expression. So to eliminate that expression is ato siyang i-divide og n plus 1. Diba? So ganina is natay x cubed, diba? Then if we try to get the derivative is we bring down 3, then x, then minus 1 in the exponent. So that's 3x squared. So again, in the fourth formula, so to go back to x cubed, so you have 3x then plus 1, diba? Cube na. Then we need to eliminate 3 man. So that's why it's n plus 1. So 3 sad. So mana we have the original equation again. So mana siya. So of course plus c gyapon. Okay? So ana reverse lang siya. Dili kay siya lisod i-follow because you have a validation coming from your derivatives. So lastly is the logarithmic integral. So in your differential calculus, so the derivative of ln is du over u. So of course, if we integrate this one, mabalik siya diri sa ln of u plus c. Okay, so take note that in your exponent rule, so as long as n is not equal to negative 1, so pwede rin yung gamiton ang fourth rule because if n is equal to negative 1, so the resulting equation would be undefined. Okay, may mo siyang u to the power of 0 all over 0, di ba? So kani siyang numerator may mo 1 kay any number raised to the power of 0 is 1 and then divided by 0, di ba? So any number divided by 0 is undefined. Okay? So question so far or clarification before we proceed with the examples? Okay, so I think there's none. Okay, so let's proceed with the first example. So we're going to have 10 examples and hopefully we finish them all by the end of the session. So yesterday is up until 7 naman siguro mi. So let's try to finish all the examples. Okay, so in the first example, so I suggest that you organize your solutions well so that in checking of exams later on, so it would be easy for me to check and of course to give you an exact remark for your solution. So again, I can tell if you copied the equation online, okay, there will be missing steps that will be ma-miss out ninyo, hindi ka suwat ninyo. Okay? So again, if you try to read the equation, that will be the integral or the integral of 5x with respect to x. So again, if we determine the integrand, so the integrand is 5x and the variable of integration is x. Okay, so again, if we try to recall the 5 basic formulas, so since we have 5 as the constant, so we try to factor out 5 outside the integral symbol. Then we have x dx. Okay, so next is we integrate this one. So that will be x, diba? So to the power of 1 siya. So plus 1 all over 1 plus 1. So again, I'll try to be very basic sa karon. I'll try to show it all. So plus c, di ba na? So the resulting equation is 5. So x squared all over 2 plus c. Then we have 5x squared all over 2 plus 5c. So again, your 5c can be combined into one big C gapon because since we don't know the value of C, and regardless of how many times we multiply it, maskin ka 1 million pa nato i-multiply, constant gapon siya. Okay, so 5x squared all over 2 plus C. So this will be your final answer. Okay, so again, try to be very organized in presenting your solutions and try to make it complete as possible. Okay, labi na sa karong first half sa semester, so we'll be asking for the solution jud. Okay, so questions? Okay, so let's go on to the next example. Okay, so we have the integral of x cubed plus 4 with respect to x. So again, following the basic formulas, so we try to distribute first. Okay, so we have x cubed dx plus 4 dx. Okay. So again, since we have 4 as the constant, so ako lang siyang i-kuhan jud, i-detail explain so that you can review this later. So factor out 4 and then integral of dx. So in the first integral is we're going to have the exponent rule. So that's x to the power of 4. So 3 plus 1. 3 plus 1 plus c. And in the second term, that's 4 times x plus c. So derivative of 1, derivative of dx is x. So more likely the shortcut of the integral of dx is eliminate the snake kaning bitin na then eliminate sad ang kaning sad ang d. So wana x in it so. Okay, so the resulting equation will be x to the power 4 all over 4 plus c, then plus 4x plus 4c. So you can combine the two c's. So the final answer will be x to the power 4 all over 4 plus 4x plus c. So, muna siya inyong final answer. Okay? So, questions or clarification? Okay, so murag wala. So, let's proceed with the next example. So, we have the integral of 3t squared plus t over 2 with respect to t. So, we have a different variable of integration in this example. So, again, distribute. So, kaning mga arrow is just for the sake of visual presentation. So, later on, pwede ra walay arrow para dili kayo hugaw inyong solution. So, the integral of 3t squared. So, again, since we distribute it, so 3t squared dt plus integral of t all over 2 dt. So, since we have constants, so 3 integral of t squared dt. And the second term is we also have a constant of 1/2. So t dt. Okay, so next is we integrate the first integral. So 3. So that will be t squared plus 1 all over 2 plus 1 plus c. And plus the second term. So that will be 1/2. Then we have t 1 plus 1 all over 1 plus 1 plus c. Okay, so finalizing your answer is we have 3 times t cubed all over 3 plus c. Oops. Plus c. Then plus 1/2. Then t squared all over 2 plus c. So final answer will be t cubed plus 3c plus t squared all over 4 plus c all over 2. So combining all the constants, so the final answer is t cubed plus t squared all over 4 plus c. So that's the final answer of this example. So sisiyo pa kayo, no? Okay, so let's proceed with the next example. Yeah, so ako sa ikaw na i-erase. Na-erase na siya. Okay, so we have ako sa ikaw na. Okay, so we have the next example. So we have a longer equation. So again, if ato na lang kanang kuan, ato na nasabtan ng ato ang basic nga process. So you can just keep with the constants, and then you can kanang create your own style of kanang getting the solution, but dili po dingon na super shortcut, di ba? So for example, dire is x to the power of 3 halves dx. So gibuhat ko nga ako siya i-distribute, so without the arrows. Then in the second term is I know that we have a constant of 3. So ako siyang igawa sa equation, 3x dx. Then plus, again, the last term is a constant, so 14 dx. So walay magic na itabo, di ba? But again, detailed gyapon siya nga solution. But di lang kay siya super basic nga detailed nga explanation or solution. Okay, so let's say is ato lang siyang butang ag c at the end. So I can just work the first equation without a c, di ba? So plus 1. Then 3 halves plus 1. Then minus 3. Then this one is x 1 plus 1 all over 1 plus 1. Then plus 14x. Then dili na ko magbutang og c sa end na big C. Okay, para lang yapon iba na ko c diri, na ko c diri sa second equation, na ko c diri at the third equation. Ya ako ra siyang i-group together into one big C. So kanina is ako lang ipakita ang katong process of obtaining the group together nga C. Mabisa kung saan pa ninyo multiply o constant, it will result into one big constant nga parameter. Okay, so our problem here is usually we don't know how to add fractions, or we have difficulty in adding fractions. Okay, murag samak mo ng mga fractions, di ba? So for example, let's try to change color lang for a while. Okay, so for example, is we have 3 halves plus 1. So akong technique diri is, since I have one whole number, one fraction, so I'm going to look at the fraction. So that's over 2, diba? I'm going to observe the denominator. So the denominator is 2. So sa karing whole number is what particular numerator nga maka-result og 1 if akong denominator is 2, diba? So meaning, ako siya yung og 2, diba na? So since 1 man siya dire, so what particular numerator nga ako ibutang dire para ang resulta niya is 1. So obviously it's 2, di ba? Yeah, since we have now similar fractions, so it's easy for me to add up the fraction. So natay 5 halves. Or if you don't want this particular method, kaning shortcut, so you can just try the crisscross method na. So 1 is, it could be 1 over 1, di ba? So malabasan niya is 3 times 1, 2 times 1, all over 2 times 1. So resulting into 5 halves gapon. Okay, so try to review your fractions. So later on, we'll be dealing with radical expressions and we'll be transforming them into its equivalent exponential form. So, medyo kailangan nyo review dyan. Okay, so going back to the equation, is we have x to the power of 5 halves. And then in the denominator is we have 5 halves also, diba? 5 halves. Minus 3x squared all over 2 plus 14x plus c. So this one is not yet the final form of the equation because we still have to simplify the kaning first term. So how to simplify this is, again, if we go back to our basic division of our fractions. So, na A over B divided by C over D, di ba? Then this becomes A over B. Then mahin mo siyang multiplication, di ba? And get the reciprocal of the second term. So that's D all over C. So for example, diri ang ato ang A over B, or let's say our first term or the one term is kaning atong A over B is kaning x 5 halves. Yang kaning atong second term is atong 5 halves nga constant. So meaning nga na may mo siyang x to the power of 5 halves divided by 5 over 2, di ba? Yeah, get the reciprocal is x to the power of 5 halves times 2 fifths. So the resulting answer is x 2x to the power of 5 halves all over 5. So muna siya. So of course the final answer is 2x to the power of 5 halves all over 5 minus 3x squared all over 2 plus 14x plus c. Okay, so okay ra so far? Questions or clarifications? So I think there's none. Okay, so let's proceed with the next example. So diri na sad. So again, if you get the hang of the kanang basic formula, so the rest will be easy. And then murag ma-difficult na siya because you'll be learning new techniques na. But again, the basic formulas will be coming out in the later topics gyapon. Okay, so that will be the integral of 1 over t squared plus the integral wait sa ako sa icon. So dt plus the integral of square root of t with respect to t. So notice that we have a fraction but ang ato ang kuan is t squared, di ba? Yung atong formula for the basic formula is natay du over u. Yan kani siya kay t squared. So atong buhaton ani is we try to get the corresponding exponential form of this term. So ako pasabutan na niya is in terms of exponent. So t to the power of negative 2. So that's still equivalent to 1 over t squared. So dt. And this is what I meant earlier that if you have radical expressions, kani mga square roots or kani mga root ng mga terms, so we have to express them in exponential form also. So t to the power of 1/2 dt. Okay, so since we know that this one is in exponential form, so we can now use the exponent rule of integration. So again, since this one is not negative 1, so it's safe for us to use the exponential rule. So we have t to the power of negative 2 plus 1 all over negative 2 plus 1. Then this one is t 1/2 plus 1. Then denominator is 1/2 plus 1 also plus c. So resulting answer will be t to the power of negative 1 all over negative 1. Then this one is 1/2 plus 1. So again, that's 3 halves. So if mo kabaw na 3 halves siya, so just review it how I got 3 halves as the answer plus C. So we have negative t to the power of negative 1 plus 2t 3 halves all over 3 plus C. So this one could be the answer. And then if you want to change back the exponential form kaning usually di mataganan makitag negative exponent na. So pili siya may mong negative 1 all over t plus 2t to the power of 3 halves all over 3 plus c. So kani pili po ni siya nga answer. Okay. So questions or clarifications? Okay, so I think there's none. Okay, so let's go on to the next example. So this one is a bit difficult na. Okay, so if you try to look at the equation, so that's the integral of x to the power of 4 plus 3x raised to the 5th power times 4x cubed plus 3 with respect to x. So kung tanaw nato dire is the only possible basic way is for us to expand, di ba? So first expand first using kaning 5th power and then multiply it with 4x cubed plus 3. And then you have to group together the like terms or the common terms. Diba? So medyo is a long process. And kani siya 5th power. So you can, I guess you can use Pascal's triangle if wa mo kabawa na, you can search it inyo sa i-search online. Basta sure ko na nasa sa inyong algebra kanang Pascal's triangle kanang mga shortcut method in determining the coefficients of higher order na mga binomials kanang a plus b to the power of 4 na mga cube, mga fourth, mga fifth power na. Okay, so marag if you want to expand this, so medyo maabta siguro mga 20 minutes siguro or more, depending on how fast you can expand the equation. Now there is, of course, we can just go with the basic formula. So since na ay fifth exponent dire, so we can utilize the exponential rule, di ba? But how do we go about the exponential rule of integration? So atong button is we're going to, di ba atong formula sa kuan is u to the power of n du, di ba? So meaning we have to replace this one with u. Some of the terms here will be u. Then atong du dire is of course instead of dx may mo siyang du, di ba? Then obviously our n is the 5. Okay? So this process is normally called as the U substitution. So you can search it up online. So U substitution. So muna siya ang term. Okay? That's one basic process or technique to make your equations more simpler. Okay? So again, is we have u, di ba? Then we have du. So let's try to change color lang sa para ato ma-appreciate ang kaning technique. So again, if we're going to let one variable equal to u, di ba? So obviously, ang u na to is under sa exponent. Di ba? Kung tanaw na to dire. So obviously, kaning x to the power of 4 plus 3x. x to the power 4 plus 3x. Okay. So again, this will be our u parameter. Now, how about the other term kaning 4x cubed plus 3 dx? So notice napatay du, di ba? So we will be getting the derivative of your u parameter. So let's change color again. So again, we will be deriving this one. So du. So usually if we try to derive, di ba? So let me try to organize my solution. So if you try to integrate, if you try to derive your u, so what we normally do in your differential calculus is that's du all over dx, di ba? And then we integrate the following equation na yun. So x to the power 4, so bring down 4, then minus 1 sa exponent, and then plus, so may mong constant ang x, so plus 3. So notice the resulting equation is 4x cubed plus 3. Muna siya, di ba? 4x cubed plus 3. Now, para ma-apply na itong dx, di ba, na may dx 3, so we'll be multiplying dx to the other side. So that will be du. And then 4x cubed plus 3 times dx. Diba? So kaning term diri nga du is muna siya diri sa babaw. Du. Okay. So ang atong ibuhat ra jud is ato ra siyang gigamitan og basic formula. So one ilain. And then of course your exponent is the n. Na. So properly labeled na siya with different colors. Okay, para at least makulay sa inyong buhay, di ba? So later on, if you want to try to organize your notes, so I suggest that you buy colored pens, okay, para makalabel-label mo. But of course, during the exam, pwede po sa exam, during the exam, pwede sila mag-color pens, basta dila mo taguras ini ka sa solution. Okay, so if you try to replace every term, so that's u to the power of 5 du. So super basic na siya, di ba? So also take note that our u parameter and our du parameter is a difference in degree sa iyang equation. So what I mean by degree is the exponent sa kanang mga terms. So in the u parameter, so it has a higher term or a higher degree, 4th degree siya, di ba? Compared sa inyong du nga 3rd degree. So one technique also in observing this particular u sub technique is dapat inika-derive ninyo sa inyong u ang iyang resulting derivative is nanandiri sa yung other side para maka-replace mo tanan sa mga parts sa original equation. Okay, so this will be u to the power of 6 na if shortcut na kanang di na mag plus 1 u to the power of 6 over 6 plus c. And then of course ang kanang din na siya mga answer because we need to replace u back in the equation. So the final answer is x to the power 4 plus 3x to the power of 6 all over 6 plus c. So muna siya ang inyong final answer. So if you are skeptical about this particular process, so you can always derive the final answer to check if your solution is correct. So let's try to derive. So x to the power 4. So ato lang i-change yung color kay para dili kay siya pareha sa kuan. Kaya purple lang. So x to the power 4 plus 3x to the power of 6 all over 6 plus c. So getting the derivative, bring down 6, diba? So 6 x to the power of 4 plus 3x. So minus 1 ang 6, 5 na lang all over 6. Then get the derivative of x, diba? Okay, kuha mo na siya nx n minus 1 dx, diba? Mauna siya ang formula sa itong derivative. So, get the derivative sa inside. So, that's 4x cubed plus 3 plus 0. So, cancel out 6. Cancel out 6. So, the final answer is x to the power 4 plus 3x to the power 5, 4x cubed plus 3. So the same as the original equation. So mura na siya. Okay, so questions or clarifications? So again, the purpose of the u sub is for us to achieve a basic form of the integrand. So muna u sub siya because our formulas are all expressed in u's, di ba? Okay, so question?
Sir, question, sir.
Mm.
Ang sa pag-integrate ganan, sir, na wala lagi ng coordinates kasi sir, sa substitution.
Okay, na mo siyang du kani siya nga akong ikuha na. So, 'di ba, muna itong u, 'di ba, kani siya? Sama siya ma-red. Ito nga. So, muna siya itong u parameter, 'di ba? The x squared, x to the power of 4 plus 3x. So, muna siya diri kani. Then, kani siya ato siyang i-derive, 'di ba? Kaning x to the power of 4 plus 3x. Now, yung resulting derivative is kani, 'di ba? 4x cubed plus 3. Then atong i-multiply dx kay mao man siya ang proper way of getting the derivative. So para ma-isolate ang du is atong i-multiply ang dx to the other side. So muna na mo siyang 4x cubed plus 3 dx which happens to be the kaning second term sa inyong kuan. So muna siya ang nahimong du. Kani siya kay u, di ba? So muna sa resulting kuan na substitution kani lang ani gawas kani. Na. So muna mas maayo na joy kanang color, di ba? Kayo papatay color manglisod ta og kanang trace back sa atong kuan. So muna sige lang ni correct example ako magyapong koloran gyapon kay para mag-guide mo. Okay, so you can always review the kuan, the recording. Okay, so questions? Any more questions? Questions? Okay, so I think we can proceed with the next example. So kani siya. So we have the integral of x squared plus 4 raised to the power of 7 times x with respect to x. Okay. Oops. So again, we're going to use u sub since we have the exponent of 7. So this muna siya tong n, di ba? And then again, we're going to achieve the basic formula of u to the power of n du. Okay, so let's change color lang sa. So again, u is under the exponent, di ba? Kani siya. So, kung sa ubos sa exponent, is muna siya ato ang u. Kay we are going to follow the basic formula. Okay, so our u parameter is x squared plus 4. So automatically this term is your u parameter. So atong batang arrow anak, arrow. Okay, so let's change color na sad. Na, so next is since namatay du dire, kani siya du. So our du is ato siyang kuhaon dire sa inyong u parameter by getting its derivative. So du all over dx is equivalent to x, diba? 2x plus 0. Or its particular derivative is du over dx is equal to 2x. Okay, so take note that there is ato ang right side, kaning remaining terms nga atong kailangan i-replace is x dx. Diba? Kani x dx is siya. And there is, we have 2x. So if we multiply dx to the other side, so what will happen is natay 2, di ba? So 2x dx. Yung atong kailangan is kaniman ang x dx man, di ba? For it to be the same sa babaw nga x dx. So atong i-divide na ng 2. So what will happen is we have du all over 2 is equivalent to x dx. So natay x dx na dire, di ba? Kani siya, x dx na siya. So meaning if ato na siyang i-replace dire, so kaning x dx will become du all over 2. So gets ra? Okay, so by replacing every term in the equation, so we can replace everything, di ba? Kaya there's nothing left for us to replace or for us to substitute with u parameter. So the integral of, so that's u to the power of 7, then our x dx is du all over 2. Okay, so you can take the 1/2 outside the equation. So that's u to the power of 7 du. Okay? So basic na siya. So the final answer is 1/2 u to the power of 8 all over 8 plus c. Then you have u to the power of 8 all over 16 plus c. So don't forget to bring back the value of your u parameter. So that's x squared plus 4 to the power of 8 all over 16 plus c. Okay, so muna siya ang inyong final answer. So questions or clarifications? Okay, so take note that the u sub is applicable to any basic formula. Dili lang kaning kanang exponent rule sa integration. So it could also be in the logarithmic aspect. Okay, so moving on with the next example. So the same stuff gyapon, di ba? So again, to the power of 4. So this will be our n. So notice the other term has no exponent, di ba? Kani siya dire, wala exponent dire. And always take note that whatever the term is under sa n, dapat mas higher siya sa other term. So natay 3 dire, dapat mas higher niya 3 sa other term. So kani siya 2. So you can use u sub. Okay? Okay, so for u parameter, so that will be x cubed plus 6x. So again, this will be the u parameter. Now, then getting the derivative of your u parameter. So this will be du. So that's 3x squared plus 6, diba? Du over dx na siya. Or in shortcut terms, kanang kibawa na mo sa kanang process gani, kanang di na kayo mo magkuhan sa over du. So usually what I do is 3x squared plus 6. Yeah, ako ang dx dito sa other end na dx. So notice nga ang kaning term dire 3x squared plus 6. Ang nasa babaw is 6x squared plus 12. So marag kailangan siya i-multiply og 2, di ba? So what you do is we multiply it by 2 kaning whole term, pa kaning whole equation. So meaning both sides are being multiplied by 2. So you have 2 du. Then you have 2 times 3x squared plus 6 dx. Diba? So meaning na 2 sa other side, diba? So balance ang equation. O atay gipuno nga dili maka create og inequality. So distribute the 2 inside the parenthesis. So that's 2 du. Then we have 6x squared plus 12 dx. So notice that this term is already equivalent to the last replaceable term in the given integral. So kani siya. So meaning kani siya is equivalent to 2 du. Na so malingaw ra jud mga ning integral kay para na ako mas lingaw siya compared sa differential calculus kay sa differential calculus there are many topics to consider, but there is integral is you only be learning techniques in integration. So murag ang counterpart niya is katulad yung derivatives. Okay, so replacing all the terms, so that's u to the power of n, and then again the second term is 2 du. So we take the constant outside, so that's u to the power of 4 du. So integrating is we have 2 u to the power of 5 all over 5 plus c. So final answer is 2 times x cubed plus 6x. So bring back the value of the u parameter to the power of 5 all over 5 plus c. Okay. So I think we can finish with the last two examples. Okay, we still have 15 minutes left. Okay, so we have another example, but this time is dili siya mohaom sa inyong exponential rule. So this time is our higher degree is in the denominator, di ba? Yeah, ang babaw is the lower degree, x t extra. So there is, since we don't know yet what particular basic formula we're going to use, so always let u be the higher degree or be the higher exponent ba kanang higher term nga kon. So meaning ana ang ato ang u parameter is the x squared plus 1. So u is equal to x squared plus 1. Then getting the derivative of your x squared plus 1, so du is equivalent to 2x dx. Diba? So again, the numerator is x dx only. So we have to divide by 2. So that's du all over 2 is equivalent to x dx. So notice that we can replace every term in the equation. So x dx is du over 2. Di ba? Dire. So ato ng koloran kay para makita dyan ang katag. And then your x squared plus 1 is your u parameter. So notice na ang magawa sa inyong final answer is more likely of the katong natural logarithm nga particular integral, di ba? So murag kuan siya kanang du all over u ang iyahang basic formula. Okay, so if we try to replace everything in terms of u, so that's du all over 2. So divided by u. So take 1/2 outside the equation. Sakto ba, di ba? Okay, if ato na siyang ikuan, 1/2 divided by 1 is 1/2 gyapon, di ba? Okay, bisag kung saan nag-reciprocal, 1 man gyapon siya, di ba? 1/2 gyapon. So 1/2 integral of 1 over u with respect to u. So du all over u. So the answer is 1/2 ln of u plus c. So again, if you bring back the value of u, this will be the final answer. Ln x squared plus 1 plus c. So, okay na? Okay, so let's go on to the last example. So, last example is, kung tanawin nyo, u to the power, u squared plus 1 squared all over u cubed. So, if we try to use the u sub here, so let's try using u sub. Kung tanawin nyo ang ato ang kuan, if mo na siya ang exponent, di ba? Ang nakasulod sa, so let's say mo na siya tong n. If you try to observe the exponent, u to the u squared is lesser than u cubed, di ba? So dito kagamit itong exponential rule nga u sub. Now kani, since muna, kanang usually don't overthink the problem, so you can just expand the term, di ba? Okay, since squared naman siya. So may mo siyang u squared plus 1, then u squared plus 1, di ba? All over u cubed du. Okay, basin puro ra anong nga ba, u sub lang yung ginuhuna, then you miss the very basic concept sad. So expanding is you have u to the power of 4 plus 2u squared plus 1 all over u cubed du. Okay, so in basic algebra terms, or in basic algebra nga property, so we can separate it into 3 terms. So you have integral of u to the power of 4 u cubed du. plus 2 integral of u squared u cubed plus integral of so napa na siya du dire, then du all over u cubed. So in simplified terms, that's integral of u with respect to du with respect to u plus 2 integral of du all over u plus integral of du all over u cubed. So muna siya. So that's u squared all over 2 plus 2 ln u. And then this one is sama siya, negative 2, di ba? So instead of plus, minus na siya dahil. So minus 1 all over 2 u squared plus c. Nakakuha lang i-shortcut kay it's kuha na. So kamalay basic ana. Okay, so I think that's it for this session. So any more questions or clarifications? Okay, so if there's none, so I think we'll meet next meeting Thursday for the next lesson.